Hi everyone. In this video, we're going to just work through one problem. And in this case, it's a multiplication of two rational expressions. Remember, a rational expression is a fraction made up of two polynomials. Polynomial on top, polynomial on the bottom. So this, let's see, this is a rational expression. Y to the third minus 8 divided by y squared minus 4. That's a rational expression. This is another rational expression. And we have two expressions multiplied together. So multiplication of rational expressions. Now, whether it's multiplication or division, doesn't matter. We start off the same way. Step one is to factor. We want to look at each component separately. So we could focus in on the numerator, the top of the first fraction, and ignore the other three. Right? We could factor that. Right? Then we could look at the denominator of the first fraction. Ignore the rest. Factor that. So we're going to go top of the first, bottom of the first, top of the second, bottom of the second. And now to factor, we're going to have to use some of our special factoring formulas. There's three of them. Two of them are going to apply in this problem. So we have the difference of squares formula. So when you have something squared minus something squared, that always factors the same way. A minus B times A plus B. Then we've got difference of cubes. A cubed minus B cubed is equal to A minus B multiplied by A squared minus A times B plus B squared. And then we've got the sum of cubes. If you have a perfect cube plus a perfect cube, A cubed plus B cubed, and that's going to be equal to A plus B. It's very similar to the one above it, just the signs are different. A squared plus AB plus B squared. So let's start with the y cubed minus 8. Well, y cubed minus 8, that's a cube. It's a perfect cube minus a perfect cube because 8 is 2 times 2 times 2. So that's y to the third power minus 2 to the third power. And then on the bottom, the y squared minus 4, that's a square minus another perfect square. 4 is 2 squared, 2 times 2. Then we've got a y plus 2 and a 5y. This is not factored yet. This is not factored yet. This is just written in the form so it matches up with one of these factoring formulas. So the first one, a squared minus b squared, that applies to the y squared minus 4, and the a cubed minus b cubed, that applies to the y cubed plus 8. The third one on the bottom, we don't need it. So for the y cubed minus 8 or y cubed minus 2 cubed, the a in this case would be the y, and the b in this case would be the 2. We have something cubed minus something cubed. The two somethings, when I say something minus something cubed, the first base is the y, and the second base is the 2. So that's your a and your b in this formula. And you don't have to think about how to factor. Once you've identified that it's a cube minus a cube, you plug those two numbers, those two values, y and 2, in for the a and the b in the formula. So that's going to be equal to. So we want to take this original problem and rewrite it so that each fraction, the top is in factored form and the bottom is in factored form. So y cubed minus 2 cubed would be y minus 2 times a squared. In this case, the a is the y. So that's y squared minus a times b, y times 2. So minus 2y plus b squared. In this case, the b is the 2. So that's 2 squared, which is 4. So that's the factored form of the numerator of the first fraction. Then we've got the squares on the bottom, y squared minus 2 squared. So in that case, again, the a is the y. In this, to match it up with the formula, the a and the b in the formula will become a is the y, b is the 2. So that will be y minus 2 times y plus 2. The fraction on the right, y plus 2 divided by 5y. Well, y plus 2, that doesn't factor. There's no common factors. There's nothing to do with that. I'm just going to put parentheses around it, sort of align it with everything else the way it's written. And then there's a 5y on the bottom. So multiplication, top times top over bottom times bottom, we could write this as one big fraction. We've got a y minus 2. We've got a y squared minus 2y plus 4. And we've got a y plus 2, right? That's top times top. And then bottom times bottom. I usually put the parentheses last, so I'll put the 5y out front. It doesn't matter if you put it at the end. Y minus 2, y plus 2. Okay, so we factored the top, we factored the bottom, we've multiplied top times top, we've multiplied bottom times bottom, and now it's in perfect form to start canceling things out. We've got a y plus 2 on top and a y plus 2 on the bottom. So if we look right there, anything over itself is equal to 1, which is why we're allowed to cancel those common factors top and bottom. And then we've got a y minus 2 and a y minus 2, one on the top, one on the bottom. So they will cancel. Y minus 2, y minus 2. Once everything is factored and all of the common factors are canceled off, whatever's left is our simplified answer. Y squared minus 2y plus 4. We no longer need the parentheses because everything that was being multiplied by actually canceled off on top. And we've got a 5y on the bottom. So this would be our final answer. Okay, so the steps of this particular problem are important, but more in general, every single time we're multiplying or dividing rational expressions, fraction of polynomials times a fraction of polynomials. Step 1, factor everything. Factor the top and bottom of the first fraction, factor the top and bottom of the second fraction. And then any common factors on the top and the bottom. We had a y plus 2 on top, y plus 2 on the bottom. We had a y minus 2 on top, a y minus 2 on the bottom. They all cancel. And whatever's left over after the canceling is our final answer. Okay, these three special factoring formulas. Now, the third one didn't apply. I'll say does not apply to this particular problem. But these three factoring formulas come up relatively often. So you want to either have these written down somewhere or use a formula sheet that contains these three special factoring formulas. All right, that's it for this problem. I hope this was helpful.